Hello, this is Ira again. So today we're going to take a look at 181001 valves, knowledge K1.02. We're going to talk about tanks. We're going to talk about relief valve bench tested. We're also going to go back and do a little bit of blowdown and accumulation exercises. In this section, we already know the concept, so it's not going to be too hard. So let's jump right into tanks. So we're gonna take a look at tanks. So we have two tanks, and they're gonna give us these problems where we're gonna have two tanks. One of the tanks is gonna just have water at a certain pressure, and this is what they call an incompressible vessel or incompressible fluid. And an incompressible fluid is a fluid where the density does not change with changes in pressure. But there are no incompressible fluids. All fluids are compressible, but the amount of pressure required to compress that fluid, or said in other words, to change the volume of the fluid, is going to depend on the fluid in question. So, for example, we can compress air more easily, and we are going to require less amounts of pressure than if we try to compress water, right? So in general, gases are easier to compress than liquids, and that's something due to something called the weak intermolecular cohesive forces. And we can also say that every fluid has a magnitude of compressibility. So what's going to happen with tank A? Tank A is going to have like a certain pressure put in. So, and because tank A contains an incompressible fluid, or what we call a solid system, since we need more force to compress a fluid, when the valve opens, we will have a rapid pressure drop and a faster initial pressure reduction because we are more dense. As well, we're going to have a faster mass loss. That's basically all we need to know about that. Whereas tank B is different because tank B is going to be a saturated vessel. So what is that? So saturation temperature is the temperature at which a pure substance changes phase at a given pressure. But we also have the concept of saturated pressure, which is the pressure at which a pure substance changes phase at a given temperature. So the temperature at which water starts boiling, for instance, is going to depend on the pressure. Therefore, if the pressure is fixed, so is the boiling temperature. And water boils at 100 Celsius at 1 atmosphere pressure. But let's go back to our problem. What do we need to know for the GFEs? For tank B, when the valve opens, there's going to be a pressure reduction that is going to cause some of the water to immediately flash to steam. And it's like we can see it at an Instapot. You know, when you have an Instapot and you're cooking and you open the valve of the Instapot, you're going to have some flash to steam. It's going to be flashing to steam because it needs to reduce the pressure inside. We apply pressure to cook faster, right? So what we're trying to do once we're done cooking using the Instapot is trying to reduce the pressure. So we're going to have this flash to steam. So initially we're going to tend to see a smaller like initial mass because it's a gas. But because we are releasing some of the gas, and it's gonna be less dense than a liquid. So that's why we're gonna have this smaller initial loss. But ultimately, we will have a larger mass release because if you see the tank, half of the tank is gonna be full with steam. If we open the valve, we're gonna release all that steam out. So things that we need to know for the GFEs is for tank B. If we have a saturated vessel, when the valve opens, pressure reduction is going to cause some water to immediately flash to steam. We're going to have a larger mass release, but a smaller initial mass loss. The next thing that we need to know for the GFEs is going to be about the relief valve. It's something called the bench test. Periodic testing and adjustment of pressure safety valve is essential for maintenance and to keep the valve safe. The most common test method for safety valve and release valve is something that is called bench test. And this test typically occurs in conjunction with inspection and repair So they have to disassemble the valve and do maintenance. It is a way to test and keep this maintenance to the valve to make sure that it works properly. The question asked in the GFEs bank about the pressure in the system. So in these problems, we are giving the pressure when the valve is bench tested and the discharge pressure. The only thing that we need to do to get the system pressure is just to add both of them, and that will give us the system pressure. And that's basically all we need to know for that. Okay, now let's go to the GFEs questions. Okay, now we start with like a couple questions, like for instance, the primary purpose of the safety valve, maintain system integrity. So we have that in here as well, maintain system integrity. But let's go and take a look at some examples. So the other questions, we can derive them from what we already have in here. It's already there. But I would like to go and take a look at some of these questions here. Let's take a look at this one. This one has a relief valve. So here we're gonna have two identical pressure vessels with identical relief valve protection. Both vessels have been pressurized to 50 psig and then isolated. Vessel A is completely filled with water. So what do we say to this one? This is an incompressible vessel, right? Incompressible. And vessel B is a saturated condition, right? Saturated. Half steam, half water. If both relief valves fully open simultaneously, the faster pressure reduction will occur in vessels. So what do we remember? The faster pressure reduction is going to occur in the incompressible vessel. In this case, it's going to be in tank A. And if both relief valve closes at 40 psig, the greatest mass loss will have occurred. So do we remember where the greatest mass loss? Yes, it's going to occur in Bravo, right? Because all this mass is going to be gone. So we're going to have, it's going to be Bravo. So you see, so from this like small example here, information, we can solve this type of questions here. Okay, the next one. Let's go and take a look at something a little bit more interesting. Some of the other questions are very similar. It's going to be similar. It's going to be asking the same questions. And we have all the information here to solve for these questions. Okay, this one is a little bit more interesting. This one, it takes us back to the concept of blow down and accumulation. That's where it takes us back. So a completely full water storage tank is being hydrostatically tested at 200 psig using a PDP with a smooth and constant discharge of 6 GPM. Okay, so here we have 6 GPM hydrostatically tested to 200 psig. So the tank is protected by two relief valves. So we're going to have here two relief valves, and they're going to be discharging to atmosphere. For relief valve A, opening set point is going to be 200 psig with an accumulation of 1.5%. And valve B is going to have an accumulation of 3%. So they have different accumulation. So what does that mean? So that means that this valve, when it's fully open, is going to be fully open at a lower pressure than this one. This one, it requires more accumulation, meaning that it was going to require more pressure to be fully open. So when the PDP, well, it says each valve has a linear flow characteristic and a maximum discharge flow rate of 6 GPM. With the PDP running continuously, what will be the discharge flow rates of the relief valves when the tank pressure stabilizes? Okay, so when is the tank pressure gonna stabilize? So the tank pressure has to, obviously, it's gonna stabilize at a certain pressure, but both of them are gonna have different pressures when fully open. So the first thing that we need to do, we need to figure it out. When is each one of them gonna have a fully open pressure? So we need to start looking into that. We have this valve, so we're gonna start with A. It has an accumulation of 1.5, and we need to solve for fully open. And the set point, we said that we start at set point of 200 psig over 200 psig. And the next one is fully open. We get our calculators here. So this one is gonna open at 203 psig, fully open. So the next one is gonna have 206 psig. So both are gonna be fully open at a different pressure, and it's obvious because they have different accumulations. So then I like to have this table because I like to see, okay, for my valve A and valve B, I know that this one here is gonna be open 203. So what I do is I do my table. And each one, we said that it had a maximum flow rate of 6 GPM, like each one of them. So I know the maximum flow rate is gonna be 6. So I know that, at this pressure, at my starting pressure, I have 0 flow at my set point. Then I start open and I start increasing my flow. So that's kind of like how I do it. And then let's do the next one. The next one is, it goes all the way to 206. Okay, so now I know that this one goes all the way to 6 GPM, so I know that I just fill in the blanks. But what's happening? So how do I know how much flow is getting out from these valves? Both valves, they have a 6 GPM. I can get out 6 GPM out of this, but I'm only getting in 6, right? So I know that they have to be, if I let them open at 200, I know that they gotta be the same pressure, right? So they're gonna be at the same pressure when I start letting them open. But how do I know, right? In other problems, we have seen that when we have a relief valve, usually one of them opens completely, but this is not gonna be the case. So let's analyze this one. So at 200, on both of them, I have 0. Then if I move to 201, I increase my pressure. This is the amount of flow that I'm gonna have from both of them. I'm gonna have 3 GPM. My pressure keeps increasing, right? Then at 202, the flow that I'm gonna get out from both of them is gonna be 6 GPM. If I keep increasing my pressure, it says that I'm gonna have 9, but that's not the case because I only have 6 GPM coming out. So the answer to the question is gonna be here. It's gonna be this part. So at 202 psig, valve A is gonna be getting out 4 GPM and valve B is gonna be getting out 2 GPM. Sometimes it doesn't ask you about the flow, sometimes it asks you about the pressure, and if you use like this, this blog thing, you will be able to get that information as well. And this is a different way to get information or problems related to accumulation and, well, not blow down, but this one is for accumulation. So now we have another example here. This is fairly similar. Now this one is asking us at what pressure, right, will the tank stabilize? This is interesting because here we have a tank that is being hydrostatic tested at 180, and it uses a positive displacement pump with a smooth discharge flow rate of 6 GPM. Okay, so we have a flow rate of 6 GPM. The tank is protected by 2 relief valves that discharge to atmosphere. The relief valve have the following characteristics. Relief valve A, the set point. So we have different set points here. So the set point for this one is 180. For B is 200. But both have the same accumulation. And each relief valve can get out 4 GPM, right? So that's going to be slightly different than the other one. It's not going to be completely the same. What we need to solve for first is we need to solve for, we are given the accumulation and we're given the set point for each one. So they're going to open, let's see, they're going to be fully open at what pressure, and that's what we need to solve for that initially. So I start solving this. So both have the same set point, so 5% accumulation, valve fully open, minus 180 over 180, and we use our calculators, and that's going to give us 189. Then 5%, that's for, this for A, this one is for B. We're solving for this one. This one has a different set point, is 200. So now we use our calculator, and the pressure when the valve is fully open for B is going to be 210. This is a little bit different. It's not similar like the other one. The other one, it was more easy, more straightforward. So both valves can only have a maximum relief of 4 GPM, right? So at 180, the relief valve is gonna start lifting at 180. So relief valve A is gonna start opening first, right? And then when we reach the 200 psig, we're gonna open next. But remember, we can only get out 6 GPM. So we know that the valve is gonna be fully open when we reach 189, which is lower than 200. So it hasn't reached the 200 yet, and this valve is gonna be fully open. So when we reach 189, we're gonna be getting out from valve A 4 GPM. So the next one, so at 200 psig is when we're gonna start getting more out of this other valve, right? So we're gonna start opening So it's gonna be 200. I'm gonna have 0 GPM. All the way until we can just do this. I don't have to write everything. So we know that this one here it's gonna get 4 GPM out, but the thing is that we cannot get there because we only have 2 GPM left in here. So when are we getting to GPM, which is half? So 2 GPM, we're gonna get in here when we are half, which is 205. I don't know if you can follow this, but because this is the maximum pressure allowed for this. So half of that pressure will be at a pressure of, half of that GPM that is the maximum allowed on this valve is going to be at 205. And at 205, we can get 2 GPM out from here. So it's asking when the PDP is still running, at what pressure will the tank stabilize? So the tank is going to stabilize until it reaches the pressure of relief valve B, because this one is already full up and it's already at maximum. You cannot do anything more about this one. This one is already giving you the full flow. But in order to keep this one, to keep opening this one and getting flow out, we need to keep increasing the pressure. The pressure keeps increasing. And when it reaches to 205, we're going to reach the equilibrium. We're going to getting in 6 GPM and getting out 6 GPM as well. So when the tank is stabilized, it's going to be at 205 PSIG, which is the right answer. And I think that will be it for today. Thank you.